I would be talking about in this part 4 about a couple of things on ASM. The first one is understanding the Oracle ASM and the association with OMF, the Oracle Managed Files. And we'll try to also understand what are the different naming conventions one can use to denote an ASM file. And towards the end of it, I'm going to talk about ASM templates. The first thing about OMF is whenever you use ASM, any database file that goes on to ASM will have its own derived name, and that's what we understand by OMF, the Oracle Managed Files, which means you cannot enforce your own naming convention while keeping files onto ASM disk group. So Oracle uses OMF for all the files stored onto ASM disk group, and the implications of this is number one, all file names are automatically derived by ASM. There is a standard naming convention that ASM follows, but all those files would have an Oracle generated name instead of a user defined name, something like system01.dbf. You will no longer see there in case of ASM environment. Which also means that if I select my archive destination onto ASM disk group, log archive format parameter would be ignored. So then whatever format you give, that's only applicable if archives are going to a file system. But if you have defined your archive destination to ASM disk group, then whatever format you select will be ignored. And you can also set an ASM disk group name as a parameter value for db create file dest, which means if I create a file going forward without mentioning the data file clause, the file will be going and sitting onto the given disk group. So here I am onto the database on a database environment, and I am selecting file names from DBA data files. You will see it has followed its own conventions, which is the location on a ASM disk group. Apart from this, you will see there's a certain standard being followed as far as the data file names are concerned, which means it includes the name of the table space followed by some number x followed by some number y, and both those numbers are changing. So Oracle decides on the names on its own. Here I am on to control file. So it follows its own location and the naming convention. See, the name of the control file is something that starts with current and so on. If I select members, you will again notice that it follows its own convention. If I select name from archived log, which is the names of my archives, you will again notice that it follows its own convention here. So under a given disk group, under the database name, it creates a separate folder and subfolders with the year, month and date format, followed by some archive convention. So the names of the archives are also derived. Now if I look at my parameter log underscore archive underscore format, you see my format is something else. So it is thread number underscore sequence number underscore reset log id dot dbf is what should be the naming convention. But if my files are going on ASM, archive logs are going on ASM, in that case the format is ignored. You can also set like in this case db create file dest to some disk group, which means going forward if I create a table space and I am absolutely silent about the data file clause, my file will be created according to the disk group value that I have set for db create file dest. So in my case, the disk group data is externally redundant. So whatever file I store going forward on this particular disk group would be externally redundant, means ASM would not do a redundant writing of the file that I have stored on this particular disk group. To get started off with, I am going to create a table space test, and pretty much that's it. If I don't mention the data file clause now, default db create file dest will be utilized, and in my case the db create file dest is a ASM disk group data which has itself an external redundancy. So if I don't mention the data file characteristics, the default data file characteristics and storage characteristics would apply, which means my data file is by default created with the initial size of 100 MB with auto extend on, with extend management for my table space as local, segment space management as automatic, extend sizing as auto allocate are the default sizing characteristics that would apply. So what it's going to do now, it's creating a data file of 100 MB on my ASM disk group. It shouldn't have taken this long, but as I said, in our environment the storage is the pain point. When I look at on my ASM command prompt, I see there's a disk group called as data, within which I have a folder called as racdb, within which I have subfolders, multiple of them. For each file type, there is a folder called as archive log, control file, data file, online log, parameter file, and temp file. If I move into data file, I can see all the data files. Remember, test data file does not exist as of now. The command hasn't completed yet. So you still don't see that file. It's going to take some time. The time that it's taking an unusual high time is because there's a rebalancing operation that is going in the background. Yesterday when we created this disk group, the last thing where we left our setup intact was I replaced disk 3 with disk 4. Now for today's demo, I want that disk 3 to be out of that particular disk group, so I am removing it. The removal command is done, but the rebalancing is still in progress. On top of that, I have also hammered my ASM with 100 MB of additional IO, so it's going to take somewhat time. So when you store the files onto ASM, understand that AMF is what will be used by default. Now question is, what if I am not happy with those strange looking names for my data files? I have shown you earlier those files seems to have some strange looking names. Before we go and take a deep dive into understanding why are those names derived in a certain way, let's understand what if I am not happy with the ASM's OMF way of naming it. Then in that case you can create yourself an alias. An alias is like a symbolic link. Although you cannot see it, but while referring to a file you can either refer to its alias or to its original name. So see here, let's say I am not happy with the name users.259.some number, in which case so here I am, this is my current path. If I don't want that name, I can create a directory on ASM, some name, let's say mydir. You can see now there's a directory called as mydir. I can go into mydir, I can say ls, there's nothing so far in this directory. Now I can create an alias for some file which would be a much readable name for me. So there's a command called as mkalias, which takes the first argument as source file and the next argument, like in a symbolic link, it takes the name of the target. I want to name this going forward as user01.dbf. If you see ls-l now, you can see actually it's like a symbolic link. So naming user 101.dbf or naming that much complex plus data ragdb data file users dot some number, you can use alternately any of those names. Remember, the user 01.dbf is an alias and the actual file still is this one. Now once my table space is created, I want to requery to see if those aliases are reflected here. Answer is no. See here, the aliases don't reflect here. So file name for database is still the original name. However, if you are unhappy, you can create an alias so that you can establish a more logical relationship between the human readable names and the OMF names by creating aliases the way we created. Now question is, what if I want to create a file and I do not want a strange looking name to appear in my file name column of DBA data files? Is there any possibility? Answer is yes, with a small catch though. So I am saying create a table space demo data file and I can give my own name now. See here, I am mentioning my own name. I am creating a tiny file to avoid unnecessary IO. I am creating a file with my own name, which is not recommended. And once the file gets created, you will realize what is the catch there. Although you can see that new name, user defined name, so I am querying it from here. Good. Now at least I can get a more human readable name for a data file instead of those strange looking OMF names. But the catch is, if I go here and say data, see here, so although it looks like it has allowed me to create a file, it actually created an alias and the file name still is the OMF name. So do whatever, you cannot force ASM to pick up your own names. To some extent, if you want, you can relieve yourself off by seeing a more readable name here, but it has no meaning. Anyways, it's like an alias created internally on a ASM disk group. So it created alias right under the disk group, whereas I created an alias under my directory, which means like a symbolic link, you can be wherever and you can point whatever file. An alias is nothing like or more synonymous to a symbolic link. If you are unhappy with the way the files are being named, I am going to my dir. I can see there's a folder there. I can always say rm alias. When I say ls-l now, that alias is no longer there. So understand the relationship between the OMF way aliases and the actual file names. Now the next thing is, why is that ASM keeps some crappy names? They are indeed not crappy, they are quite using a very standard functionality. The first thing is with a plus sign the name of the disk group, followed by, which in my case is data, followed by the name of your database, which in my case is ragdb, followed by file type, which in my case is a data file, followed by file type tag, which is derived, followed by file ID, followed by files incarnation. These two things would ensure that no two files on your disk group are having the same combination. It might so happen otherwise that I have two databases, dev1 and dev2, storing their files on the same particular disk group, and both of them have a table space called as test. So the name of the file will be still test, but that .x and y combination will always be different. So that file ID and incarnation combination would always be unique. So even if two files are stored in the same directory on the same ASM disk group, they would still have a unique name. considering this, the ASM names are far more better than human readable names, because when you give a human readable name, it's quite possible that two files might end up with the same name, probably in different directories, which is quite possible. Now, the next thing is understanding the relationship between the file type, what are the different file types, and the file type tag. So I'm going to get a ready reckoner here. So if your file type is control file, then in the name where you have some name .x .y, that file type tag would either show you current or backup for control file. So if your file type is control file, then the name of the file will always be either current.x.y or backup.x.y, depending on whether it's a backup control file or it's a current control file. So here I am on to, so see here. So if the file type is control file, then the file type tag is current or backup, followed by .x .y. Remember, .x .y will always be a unique combination. If your file type tag is data file, file type is data file, then the file type tag is name of the table space. So if you have a table space named users, data file will have the name as users.x.y, which is file ID and file incarnation. If there are more than one files, table space name would still be users, but the X and Y combination would vary. I said alter table space test, add a data file on a disk group named data. Remember, I have just given the name of the disk group, nothing else. Size 2M. I could have stopped by saying this only, because I am anyways using OMF DB create file desti set. I could have stopped there, but in that case, default file characteristics would have applied, means the file would have been of 100 MB, which I wanted to avoid that unnecessary IO. That's why I completed that command with 2 MB, followed by which if I say, so you can see there are two files now where this portion is common, but this portion is different. So that .x file ID and file incarnation would be different. So those two portions would always be uniquely generated by ASM, or rather by your OMF feature, which will ensure two files would never end up having same name. If the file is redo-log file, the file type is online log, in which case the name of the redo-log would be group_group ID. See this section, group_group ID followed by .x .y combination. If it's an archive log file, then the convention, the file type tag is thread_thread hash _seq_sequence hash. thread_thread hash seq_sequence hash. So those two numbers would always give you an unique combination. If your file is temporary file, then in the name of the file itself there would be the name of the table space followed by .x .y. If it's a RMAN backup set which includes SP file, then the name would be SP_timestamp. If it does not include SP file, then it will say instead of SP, it will N indicate that the backup set does not contains the SP file, which means for auto backups, if auto backups includes SP file, the name would be SP underscore timestamp. Otherwise, it will be NP underscore timestamp. If it's a parameter file, the name of the parameter file is SP file. Now let's understand how the parameter files are given. I am saying show parameter SP file. See where my SP file is. It's under data ragdb SP file. I am going to that location now. This is the name, which is actually an alias for something that resides under here. So although it looks like my SP file name is SP file ragdb.ora, SP file ragdb.ora, it's just a alias for the actual file which is named as SP file.x.y, which means the name contains the tag as SP file. For data guard configuration file, it will be name of your unique DB name, DB unique name parameters value. If it's a flashback log, then it will be log underscore log ID. If it's a block change tracking file going on to an ASM disk group, then the file type tag would be CTF, which is change tracking file. If it's a RMAN, if it's a export dump set, then it will have the name as user underscore job ID underscore file ID as the name. Remember, you can store your data pump sets onto a ASM disk group. The only catch there is log file is also generated. Log file has to go on a file system. It cannot go on a ASM disk group. So let's quickly simulate one. So I created two directories, one onto file system, one onto ASM. And after that, I have granted read write permission on those directories to Scott. Prior to that, I created, or rather I unlocked the Scott's account. Now I want Scott to fire an export data pump backup. So we say expdp. The only couple of things that you must remember while firing an export data pump is, while mentioning the directory of your dump file, I am mentioning my directory as asmdir. And for log files cannot be kept onto ASM. So for that, if you are using a log file attribute for logging this whole thing, then you must mention some file system directory. What is the attribute for log file? Log or log file? It's log file. So I said expdp scott slash tiger directory equal to asm dir. That's where my data pump dump file should go. Log file is equal to directory colon log file name. Once that is done, we can quickly validate it. So you can see it under the directory name dump set, and the name of the file would be user underscore job id underscore file hash. So I can see what's the name of my job here. This is the name of my job. Scott's sys underscore export underscore schema underscore 01 is the name of the export job that's currently running. And then I can go to ASM. You see there's a new directory created with the name dump set. If I say ls, see the name. This was the name of the job. This is the name of the user who fired it. So it follows user underscore job id underscore file hash. That file hash is a unique name generated again, followed by .x.y, which is anyways unique. So let's see. So it's still going on. Remember, the only thing you need to categorically remember here for doing an export data pump job, that for log files it must be a file system directory. Dump sets can go onto a disk group but not log files. So let it go. If you are using a transportable table space for cross-platform transportable table space migration, then the file that you convert ultimately as part of that exercise will have the name of the table space .x.y. If it's a auto backup, then I told you sp underscore timestamp. If it's a ASM parameter file, the file type tag would be sp file. If it's a OCR, then the tag would be OCR file. I'm jumping on to ASM one more time, going to data group 00. There's a folder called as OCR file, and if I say ls-l, the name of the file is registry.something.something. A small correction here, it looks like these conventions are not yet updated. The name of the OCR file is registry, not OCR file as such. Now you can mention the ASM file names in a multiple different formats. The first one is fully qualified ASM file name. So if your command on the database requires you to mention the complete file path, then you can always mention fqdn of ASM file name, which is in the format something like this. Clear? This is fully qualified ASM file name. Then there is something called as numeric name. A numeric name is disk group followed by x and y, disk group followed by that .x .y file id. So if I want to mention my file using fqdn, which will be like this, fully qualified ASM file name, and the same file if I want to represent here, I can go for a short convention like this, because I told you for a given disk group that x and y combination is always unique. So numeric file names are given in the format name of the disk group dot file id dot file incarnation. You can use alias ASM file name with template, which I have rather this one, alias ASM file name. While creating a file, we created with the name demo01.dbf. So you can use alias file names as well. While creating the file earlier, we gave the name as demo. Something like this. You can give alias with template, which could be of the format templates. I am going to talk in a later session, but you can mention your own template as well. which is ASM file name with template. You can also give incomplete ASM file name, which is of the type this one. This is called as an incomplete name, meaning mentioning just the disk group name and let Oracle place the file and derive the naming conventions for you. It's called as an incomplete ASM file name. You can also use incomplete ASM file name with a template, and in which case my same command could have been of the format where my template is some template that I have pre-created, is what it means. So these are the various different naming conventions that one can follow in ASM for naming the various files. Now I am going to create another disk group of the type normal redundancy. Disk names as D3, D4. Failure group as FG1, FG2. I am saying show advanced options. Categorically I am making a compatibility selection as 11.2.0, after which I said OK. So let it create the disk group. While it creates the disk group, let's understand templates. Very important discussion. Each disk group would have system defined 16 templates. So there are, for every disk group there are 16 templates. They are predefined, system defined. Now why 16? That is because 16 different files can be kept onto ASM. So for each file there is a template. So there is one template for each file type that you can store on a disk group. So understand this. Who has a template? Disk group has a template. The templates are applicable to a given disk group. How many templates are there for each disk group? There are 16 predefined templates for each disk group. Now why 16? Because there are 16 different types of files which you can keep on a given disk group. What is the role of a template? A template describes for a given disk group redundancy, striping style, and intelligent data placement. This is the role of a template. There are 16 system defined templates for a disk group with external redundancy, for a disk group with normal redundancy, and for a disk group with a high redundancy. So see what is the role of that thing. For all files, redundancy is no redundancy. For all files except control file, striping style is coarse. For all files, IDP is cold primary, cold mirror. Mirror doesn't comes in picture for external redundancy disk group. Understand this. So what is a template for? Template describes three things. For how many files? 16 different files. For each of those templates, 16 different templates that you have for a given disk group, each template which is there for a given file type describes what should be the redundancy, what should be the striping style, and what should be the intelligent data placement for that given file. Now I am querying the templates. I am querying lstmpl list template -g data. So I can see how many templates are there? 16. Let's query it in a more meaningful way by connecting to ASM. How many templates should be there? My question is, I am here in the VNC. This group is created by the way. My question is, how many templates should be there? So you can query the templates from $asm underscore template. Since we have two disk groups, disk group data, disk group DG normal. So I see 16 templates for each disk group, a total of 32 templates. These 16 templates for disk group data, which is externally redundant, describes what should be the redundancy, what should be the striping style, what should be the intelligent data placement for primary and for mirror copies. Now since I am talking about external redundancy, mirror doesn't comes in picture, but a template anyways describes these attributes. So I said for all files redundancy is no redundancy. See here, unprotected. For all files except control file, striping is coarse. Only for control file you can see fine striping. For all files, IDP is cold primary and cold mirror. Primary is cold, mirror is cold. Next I am describing the template for normal redundancy disk group. So focus here. I should pick up the correct word. Correct word is unprotected. Now understand this. There are 16 system defined templates for the disk group with normal redundancy. For all files, redundancy is mirror, except control file which has high. Understand this. If I store any of those 16 different files on my disk group with normal redundancy, how many times my file will be written? Twice. But if I store a control file and my disk group has 3 failure groups, how many times my control file will be written? 3 times. Understand this. Now I am highlighting this section, which is for disk group 2, which is DG norm. So I am now focusing on this column. So all files are two-way mirrored except control file which is three-way mirrored if possible. I can create a disk group DG normal with only 2 failure groups. With 2 failure group, can I write my control file 3 times in a redundant order? No. But if my disk group is with normal redundancy and failure groups defined are 3, all files will be written twice, only control file will be written thrice. All files except control files striping style is coarse. Only for control file it's fine striping. All files on a disk group with a normal redundancy, the primary and the mirrored region are placed in where? Cold region. Clear? Now for high. If you store your file on a disk group with a high redundancy, all 16 files are redundant highly, three-way mirror. All files except control file are coarse stripe. Only control file is fine stripe. All files, primary and mirrors are kept in cold region. Clear? Now question is, what if I do not necessarily agree with a given template? Answer is, create your own custom template. I am describing the $ASM template view. Is it a system defined template? All of them are system defined templates. What if I do not necessarily agree with the Oracle's way of storing a file? Then I have always a right to disagree by creating my own custom template. Consider this case now. Here I am on my database. I am creating a table space test1 with my data file going to DG normal size of 2 MB. What does my template says for disk group DG normal? Which file type will apply? Number 1, data file. So I am now looking at my data file template. This is the data file template of my disk group. How many times my file will be written? How many times my file will be written? 2 times. What type of striping style will be used for my data file? Coarse striping. Where will be my file placed? Primary copy will be in a cold area and mirror copy will also be there in the cold area. File is created. I do not agree with this one. I came out. I go to DG norm, ragdb, data file. How many times the file is written? What type of a striping method is used? So although my file is of 2 MB, how much actual space my file has occupied disk wise? 4 MB. Now consider another case. I want to create an index table space. How many times my file will be written on dgnorm? Twice. I want to keep my temporary file on dgnorm. How many times my file will be written? Twice. Because templates say that temp file and data files or all other files for that matter are written twice. Now here I want to mark an exception. I don't want to go with the default style. Create your own template. Here I am on here, ASMCA. I right click on a disk group. I say manage templates. Here I give my own template. I want to keep the file as unprotected. My file should be striped as fine. I want to keep my file in hot region. You can select any of those styles. I say save. Here I am. See here, you can see a custom template with this name now. I am logging into ASM. How many rows are selected? See this one. Is this a system defined template? Which means it's a user defined template. Now I want to store my temporary file. So I said create table space temp1 temp file. Create temporary table space temp1 temp file. Did I mark any exception for this file? Means default template will be used. How many times my file will be stored? 2 times. I don't believe this. So I am going to again ASMCMD. How many times my file got stored? Now question is, do you really need redundancy for temporary file? But if you don't mention, it will make it redundant. Next time I got a little more cautious while adding another temporary table space temp2 temp file. This time I am mentioning my own custom template. Clear? I am back on to here. I said ls-l, pick out the differences. So here it was mirror, here it is unprotected. Here it was coarse, here it is fine. This must have gone to a cold region, this must have gone to a hot region. This is what my template says. Clear? No, that has, this is not a template, this is a file. Template ka property, if you see, is it a system template? It will show you no. Clear? So you can mark a categorically an exception. If you disagree with Oracle, create your own custom template. Now question is, what if I want to mark a disk location as a default db create file dest along with a template? It is possible. I can say alter system set db create file dest. See here. So not only I selected another destination, I also selected the default style using which my files will be created from the redundancy perspective, from the striping perspective, and from the IDP, intelligent data placement perspective. Clear? Let's try to do the same thing with data. I have another disk group called as data. Here I am. I right click on this one. I say manage template. I create another. it doesn't allows me to select anything more because it's a externally redundant disk group. So you cannot say on a externally redundant disk group that write a file twice or thrice. You can however change the find and the IDP part. Remember, the mirror has automatically disappeared from here. I said save, it says no, nothing doing. The reason is given in the error message. To be able to use templates, your compatible.rdbms property of the disk group must be 11.2.0. That's why while creating disk group DG norm, I categorically used compatibility for all the attributes as 11.2.0. So templates are only for those where compatibility of RDBMS is 11.2.0. My disk group does not have that compatibility. I click on edit attributes and I know why it was erroring out. My database compatibility says 10.1. If I change this value, I should be able to create a template there. So these are those two disk groups, and this is the understanding of templates. Question is, whatever values I am giving, where does it stores the information about my templates? ASM does not have file, control file, data dictionary, nothing. If I keep on creating these templates, it must be storing somewhere the information about the templates. It goes as part of metadata. So all the data about your disk group goes as part of the metadata. This is the only appealing reason why somebody would like to take a backup of metadata. Otherwise, there is no appealing reason why somebody would like to take a backup of metadata. Your ASM CMD command prompt offers you MD backup command. The MD backup command creates a backup file containing metadata for one or more disk groups, volume, and Oracle ASM management cluster file system information is not backed up. So if you have volumes created inside it, if you have ACFS created on those volumes, it will not be backed up. Rest other things can be backed up. Remember, it's not a backup of data, it's a backup of metadata, which is often very tiny. So that's why Oracle offers you two commands for metadata management. One is MD backup, another is MD restore. The only appealing reason why I feel somebody would like to do a metadata backup is to preserve the templates. I don't remember categorically if this MD metadata backup was there in 11.1. Hmm. I really don't know. It only helps you take a backup of metadata. And templates were introduced in 11.2. So understand again, templates describe redundancy, striping style, and IDP. There are 16 predefined templates for a disk group of the type external, for the disk group of the type normal, and for the disk group of the type high redundancy. If you do not agree with Oracle, create your own custom templates and select your own redundancy and or striping style and or intelligent data placement conventions. Clear? Out of context, we'll be jumping otherwise. I told you earlier about aliases. You can query those aliases from your data dictionary view, not data dictionary, dynamic performance view, v$asm underscore alias. There's another dynamic performance view, v$asm underscore file. You might want to consider both. So I'm looking into v$asm underscore file and v$asm underscore alias. You can query both. You can create directories either using mkdir command, or you can add a directory using alter disgroup name add directory command. You can add alias by saying alter disgroup name add alias name for file name, or you can use mkalias command. IDP I have already described. To be able to use IDP, compatible.asm and compatible.rdbms must both be set to 11.2 or higher. Later on those IDP can be changed, by the way. I told you about disgroup templates. A templates describes striping style, fine or coarse striping, redundancy, which could be unprotected, mirror or high, followed by IDP setting. If you do not agree with Oracle any longer, you can create your own templates. You can check your templates. Using lstmpl command as well. -L is to display a long listing. Otherwise it will just display you the basic attributes of your template if you ignore this one. G is for the disgroup name. Yes. Yeah, if there exists a template for your disgroup, only then you can make use of it. You can also create a template using mktmpl command followed by those attributes. So here it's saying mktmpl-g data redundancy unprotected. You can use this way to define a template. mktmpl-g name of the disk group, striping to be selected upon from coarse or fine, redundancy could either be high, mirror or unprotected, primary copy where it should go hot or cold, secondary copy where it should go hot or cold, and what is the name of the template. You can change the template as well at a later stage using chtmpl command, and if not required then you can remove it using rmtmpl command. Edit the properties, those three things. No, not name. And then I already described you about how to use a template, how to set it as part of the default destination. Clear? So very important discussion about templates and the file naming conventions. The next part I'm going to talk about ADVM and ACFS.